Hey folks, welcome to Factoring and Solving Polynomials. This is chapter 5.4 and 5.5. They're pretty similar sections, so they're just combined. So this will be a two-part series. I'll try and do these videos in as short a time as possible. So getting started, we're going to do some factoring by just factoring out a greatest common factor. Okay, so the key is what number can divide out between 3 and 48. And that's a 3. A 3 goes into both of those. Also, they both have a y in common. And what power of y do they have in common? Well, the short answer is just pick the lowest power, which is 3. And if you ever get confused by stuff like that, if I were to just write y to the 5th power over y to the 3rd power, or not even over, just writing y to the 5th power and y to the 3rd power. Y to the 5th power is basically, it's 5 y's multiplying times one another. And y to the 3rd power is 3 y's times one another. So what do they have in common? 3 y's multiplying towards one another times one another. So that is the long explanation as to why you just pick the lowest power. So once you have your greatest common factor identified, I'll put a GCF right there. Just write it on the outside, and then you're basically dividing it out. So write what's left on the inside. What's left is y squared, because you subtract your exponents. 5 minus 3 is 2, and the 3's cancel. And 48 over 3 is 16, so minus 16. And then, see, your y's cancel all together there because it's y to the 3rd divided by y to the 3rd. So you're left with this. So this right here can actually expand to become y plus 4 times y minus 4. And then you just bring down that 3y to the 3rd. So I got this y plus 4, the y minus 4. That is your difference of squares pattern, and that's in the 5.2 part 2 notes. And that pattern is basically just take the square root of each number if you recognize that they're both perfect squares, which y squared, of course, that's a perfect squared, but 16 is a perfect square. So the square root of 16 is 4, make one plus, make one minus, and that's the difference of squares pattern right there. So this would be my final answer right here. Okay, let's move on to part B. So here we have 5, 30, and 45. So the common factor is 5. Alright, now they all have a z. What's the lowest power? 2. So I'm going to put 5z squared. And that's going to be my GCF, okay? And so I'm going to write 5z squared on the outside. And then let's see what's left behind. So my 5's will cancel, and z to the 4th over z squared leaves behind z squared. 30z to the 3rd over 5z squared is 6z. And this will just leave 9. 45 over 5, the z squareds cancel. So what do we have here? We have a trinomial right here. Well, what are the factors of 9 that add up to 6? Well, 3 plus 3 is 6, and 3 times 3 is 9. So I'm going to say it's 5z squared times z plus 3 times z plus 3. Alright, now since you have the same thing twice, just say z plus 3 squared. That's preferred because it's just shorter, and you know, in the future you see stuff written like that more often. Okay, so that would be the final answer. We factored out a GCF, and then we're left with a trinomial that we could factor like we did in my earlier videos. Okay, so let's talk about special factoring patterns. Special factoring patterns, the two to point out that I'm going to focus on for the rest of this video is sum of two cubes and difference of two cubes. That's where you have two terms where each term can be expressed as a product of, or a sum or difference of two cubes. So, for example, 64 is 4 to the third power, and then x to the third is x to the third power. 27 is 3 to the third power. 8 is 2 to the third power. 1 can be written as 1 to the third power. So you see how these are broken down. It's you want to take like the cube root of each, and then you're going to get like an a term and a b term, and then you just plug it in to these patterns right here. So if you're ever stuck on how to get your perfect cubes, or what are your perfect cubes, open up your graph and type in x to the third power, hit Control T, and looking at that table, you'll see your list of perfect cubes. Okay, so that's what I recommend you do for the future if you ever get stuck on these perfect cubes. Now, looking at these examples, we have x to the third minus 125. So we have a difference of two cubes here. So write it as the difference of two cubes. Like literally take the cube root of each. So the cube root of 125 is 5. And so I'm going to write this as x to the third minus 5 to the third. So my x is my a term, and my 5 is my b term. So then it's just a matter of plugging it into the difference of two cubes pattern right here. Okay, so the key here is it's going to go minus, plus, minus. It's the same as the sum one, but that one goes plus, minus, plus. Okay, so that's really the main difference. Alright, so here I have it written down again. I am going to write x minus 5. So don't write x minus 125. Remember, you need to express these as cubes, so 5 cubed is 125, not 125 cubed is 125. You see how that doesn't make sense? So then you're going to write x squared plus ab would be x5, right? Just write 5x. B squared is 25 because that's 5 squared. Alright, and this right here is actually the final answer. That trinomial wouldn't simplify because there are no factors of 25 that add up to 5. Your factors of 25 are 25 and 1, that adds up to 26, and 5 and 5, and that adds up to 10. So this is the final answer. Okay, so that's really all there is to say on this example. Now on B, you have to factor out a common monomial factor first. So I see they're both negative, so I'm going to make that negative. And then you might be scratching your head for a long time with what goes into 24 and what goes into 375. We'll just look at the smaller number first. So I'm going to write 24 here. And you need to, so list all the factors of 24. Okay, so what is a perfect cube? Because we want, this section's about sum and difference of cubes. So which number here is a perfect cube? And that's 8. Okay, 24 and 1, 12 and 2, 6 and 4, none of those are cubes. But 8 and 3, 8 is a cube. So if you divide it by a 3, you're leaving behind an 8, which is a perfect cube. Again, if you don't know your perfect cubes, you should be looking at the table of x to the third power, and then you'll see that 2 to the third power is 8. So I'm not going to divide it by 8. I'm going to divide it by 3 to leave behind the 8, because I'm going to try and use that perfect cube pattern. So besides, 8 doesn't go into 375, but 3 does. Go with the lowest power again, so x to the third is in common. And so this right here is our GCF, or it might not even be the greatest common factor, but it is a common factor, so I just wrote CF. Because like I said, we intentionally chose 3 because it will leave behind an 8. It leaves behind 8x to the third, and minus 375 over minus 3 becomes plus 125, and the x to the thirds cancel. So don't forget to write your common factor on the outside here. So negative 3x to the third. Now what we have is a sum of two cubes, okay? So this is what I mean. Take the cube root of 8 x to the third and 125. So the cube root of 8x to the third is 2x. So you're going to put that in parentheses and because it's together, and 2x to the third plus, and then 5 to the third. So what I just did here was I got my a and my b. So now I'm going to go and I'm going to look at my sum of two cubes pattern right here, and I'm going to just copy that pattern below. So here I have negative 3x to the third. That has nothing to do with this pattern. And then you have your a plus b, so that's going to be 2x plus 5. And then a squared is 2x squared, use parentheses, minus ab, so minus 2x times 5. And then plus b squared would be 5 squared. Okay, so the final answer here is you just simplifying that 2x squared, which is 4x squared, and then the minus 2x times 5 becomes minus 10x, and then the 5 squared becomes 25. And so we got our answer by factoring out a common monomial factor and then using the sum of two cubes pattern. Okay, so now let's talk about factoring by grouping. With factoring by grouping, you want to literally group your terms into pairs. So generally speaking, we're going to give you 4 terms, and that's how you'll know to do grouping. Because looking at it holistically, there's no greatest common factor between all 4 terms, but there's a common factor between the first pair of terms. That would be an x squared. And there is a common factor between the second 2 terms, and that will be a negative 7. If the front term is negative, you're going to want to have your greatest common factor be negative, okay? So these two are both separate GCFs for your pairs, okay? So the next thing to do is just write out the result of you factoring it out. So dividing an x squared from x to the third leaves behind x, and dividing 3x squared by x squared leaves behind 3. And then I'm going to write minus 7, because I'm factoring out a minus 7. And then that's going to leave behind an x, and then negative 21 divided by negative 7 makes positive 3. So the key here is that when you do factoring by grouping, it uncovers a hidden common binomial. So what you do is, because of the distributive property, x squared is being multiplied times x plus 3. Negative 7 is being multiplied by x plus 3. So you can combine the x squared and the minus 7 into its own binomial and just write it multiplying times x plus 3. You don't write x plus 3 squared because the distributive property means you can put the x squared minus 7 together. So we're not squaring x plus 3. We're not multiplying x plus 3 times x plus 3. We're multiplying x squared times it and negative 7 times it. And so at this point, you check to see if this is a difference of squares, but it's not, because 7 is not a perfect square. So in this case, you have your final answer at this point. All right? Let's look on to another example. So here on example B, I have a greatest common factor of x squared. I have a greatest common factor of negative 9. X squared goes into x to the third and negative 2x squared, and negative 9 goes into negative 9x and 18. Again, I'm using a negative because that front sign is negative. So let's write our intermediate result below. So dividing x to the third by x squared leaves me with x, and negative 2x squared over x squared leaves me with negative 2. Minus 9, dividing out a negative 9 from negative 9x leaves you with an x, and 18 over negative 9 makes negative 2. So what do we have here? We have a common binomial of x minus 2, so I'm going to say x squared minus 9 times x minus 2. And then what do we know about x minus 9? We know that x minus 9 is a difference of squares. So the square root of 9 is 3. So I'm going to say x plus 3 times x minus 3, and then times x minus 2. And so that is my final answer. So again, check those 5.2 notes if you need to see any other examples of difference of squares. I think there's an additional one in there. So next part, C. What is common between x to the fourth and x to the third? X to the third. What's common between negative 64 and 64? Well, negative 64x and 64. It's 64. So dividing out x to the third from x to the fourth leaves behind x, and x to the third over x to the third leaves behind 1. Minus 64, forgot to write the minus right there, leaves behind an x, and then 64 over negative 64 leaves behind a negative 1. So the idea here is that this and this will always be the same thing. That's the goal of factoring by grouping. So we're going to say x to the third minus 64 times x minus 1 times x minus, no, just times x minus 1. Yeah, I was about to say it twice. Don't do that. So this isn't the final answer, but x to the third minus 64, you have x to the third power. What do you know about 64? It's 4 to the third power. Again, check that table of x to the third. So what we have here is a difference of cubes. So because we have a difference of cubes, we're going to write it as x raised to the third minus 4 raised to the third times x minus 1. And then I'm just going to look at the difference of cubes pattern from above. So I'll copy and paste that below right now. So here's the difference of cubes pattern. So I'm going to write x minus 4 times x squared plus 4x, and then plus b squared would be 4 squared, so that's 16. So that's 4 squared. Close the parentheses and bring in that x minus 1 from before, and this would make the final answer. And that's all I can say about that. So there's 3 good examples of factoring by grouping, okay? So the last section here is solving a polynomial. And really it's just it should feel like the other sections. The only thing is solving means it's equal to 0. And if it's not equal to 0, then scratch out the f of x and write it equal to 0. Okay, because if I say solve, it means where does it equal 0, meaning where does it hit the x-axis, okay? So let's do it in order. Looking at this, you have 3 terms. Do they have a common factor with all 3 terms? You can't do factor by grouping if there's only 3 terms. Well, I guess you can, but that's another topic for another video. But if you see 4 terms, think factor by grouping. If you see 3 terms, think x factoring, okay? So first, look for our greatest common factor. So 2 can go into all of them, and x can go into all of them. So I'm going to divide out a 2x. So 2x to the third divided by 2x leaves me with an x squared. Minus 12x squared over 2x is minus 6x. Plus 18x over 2x, x's cancel, and that just leaves you with a 9. So this is what I mean by the x factoring. What are your factors of 9 that add up to negative 6? Well, negative 3 plus negative 3 is negative 6, and negative 3 times negative 3 is positive 9. So I'm going to say 2x times x minus 3 squared equals 0. Because it was minus 3 twice. So the solving is, wherever you see an x, set that equal to 0. So 2x equals 0, and x minus 3 equals 0. Well, 2 times what number equals 0? Well, anything times 0 is 0. So x equals 0 here. And then 3 minus 3 equals 0. So x equals 3. So these are the two final answers. This right here would be the final factored form. And yeah, that's all I'm looking for. Just take it one step further and tell me where it hits. What x numbers can you plug in to make it go to 0? That's where y is equaling 0, where it hits through the x-axis. Okay, so you can have you know, as low as one answer. If you look at these other examples, like this one, we'd have 3 answers because we had 3 x terms. So yeah, let's look at these next two. What's common between negative 2x to the fourth? There's no greatest. Oh, there's a greatest common factor. I was about to say because there's no x. I can factor out a negative 2. If the leading term is negative, you should factor out the negative. So if I divide all of these by negative 2, that'll give my numbers smaller. So I'm going to be left with just x to the fourth minus 8x squared plus 16. So here's the thing. It's x to the fourth power and x squared. So it's just it's like double the power from before. Just do it like normal. Like do it as if you're doing a problem where it'd say x squared. What are your factors of 16 that add up to negative 8? That will be negative 4 times negative 4 is positive 16, and negative 4 plus negative 4 is negative 8. So I'm going to say it's negative 2 times x minus 4. And since it was to the fourth power, I'm going to say x squared, okay, in my factor. And then since it was x minus 4 twice, I'm going to square that. And, you know, eventually when you distribute or whatever, or, you know, multiply it out, you'll get back to the x to the fourth. So set it equal to 0. And all I have to do is x squared minus 4 equals 0. And, well, remember the square root method? Add the other number to the other side, okay? I get x squared equals 4. So square root both sides, and remember, anytime you square root, you have a plus or minus. So the square root of 4 is plus or minus 2. So x is going to equal 2 and negative 2. And that's the final answer for B. Okay, so I know this video is running a bit long, but one more example, and it's kind of similar to example B. Because you have x to the fourth power again. But there's nothing to factor out, so you can just jump right into the x factor. What are your factors of 81 that add to negative 18? 9 times 9 is 81. But I need to make negative 9 and negative 9. That also makes 81. And that adds to negative 18. So I'm going to say x minus 9 squared. And then again, I'm going to make that x squared on the inside because of that fourth power from the beginning. Don't forget to equal it to 0. Now, you see an x, set that equal to 0. X squared minus 9 equals 0. And so you're going to add 9 to both sides, and then square root both sides. X squared equals 9. The square root of x squared is x, and the square root of 9 is plus or minus 3. So we have two answers, positive 3 and negative 3. And so that wraps it up for these notes. Thanks for watching. If you're one of my kids, don't forget to do your assignment, and stay tuned for part 2. Goodbye.